Hello students, I am Dr. Sumaya Inamdar. For BSc second semester number 4, I will teach you classical statistics. The classical statistic is a quite interesting chapter of in your academic. In this classical statistic, we'll learn the two parts. In first part, we'll learn about the degrees of freedom, position space, momentum space, phase space, macro states, micro states, thermodynamic probability, priori probability, accessible states, etc. And in second part, we learn about the Maxwell-Boltzmann statistics. So overall, classical statistic is a very interesting topic in your syllabus. So let us start with the degree of freedom. What is the degree of freedom? Consider a simple monoatomic gas system. Okay, in this system, if we are wish to write the energy expression, then this energy expression will involve F position coordinates, F momentum coordinates, and then the system comparing with one molecule, then we can say that the system has the F degrees of freedom. Okay. Similarly, if the system contains a n number of molecules, then energy expression for n molecules has n f position coordinate and f momentum coordinate, and thus the system has n f degrees of freedom. Okay. Then we move towards a very interesting part of the chapter is a position space. Suppose the system contains the n number of particles, okay, in a given volume V. Okay, system is having a n number of particle in a volume V. The system is a static system. We know that there are two types of the system. One is the static system and another one is the dynamic system. Static system, which is a fixed, means every particle is fixed at somewhere in the given volume. Okay, particles are fixed at a various position in a given volume. And another one is a dynamic system. In dynamic system, every particle is continuously moving with a certain velocity v, and in other words with the momentum p. Okay, suppose the system is containing n number of particles and having in a volume v, and the system is the static system. In such a static system, every particle is fixed at a various position, and in this condition, if we have to locate a particular point in the given volume V, we must have the knowledge of three coordinates x, y and z, and these three coordinates are mutually perpendicular to each other. Right, means if we have to define the particle in the three-dimensional, we must have the knowledge of the three coordinates x, y and z. Similarly, if the system contains the n number of particles, then we must have the knowledge of the 3n coordinates. So what is position space? The three-dimensional space in which the location of a particle is given by three position coordinates is known as the position space. So if the small volume element dv is denoted into the given position space, it can be written as dv is equal to dx, dy and dz. Okay, similarly we see another point at the momentum space. What is a momentum space? We see the two systems. One is a static system and another one is a dynamic system. In the dynamic system, we know that every particle is continuously moving with a certain velocity vx, and we can say that with the certain momentum p. Okay, if we wish to define a particle in such a dynamic system, we must have to know about the momentum of that particle, and this momentum of the particle can be defined by the velocity. Means if we know the momentum if suppose the m is the mass of the particle and it is moving with the velocity v, then p is equal to mv is the momentum of the particle, and it's a three momentum coordinates along the three axes x, y and z. Px is equal to mvx along the x axis, py is equal to mvy along the y-axis, and pz is equal to mvz along the z-axis. So the three mutually perpendicular momentum coordinates locate particle in three-dimensional space is known as the momentum space. Okay. We consider the small element in the momentum space d2, and this momentum space is defined as d2 is equal to dpx dpy dpz. It is a momentum space. Now we see the phase space. What is the phase space? Phase space is a combination of the position space and the momentum space. Means the phase space requires the six coordinates, three position coordinates x, y and z, and three momentum coordinate dpx, dpy and dpz. Means these three position coordinates and these three are the momentum coordinate. Means if we have to define the dynamical system completely, we require the six coordinates, three momentum coordinates and the three position coordinates. Means suppose the system contains the n number of particles, then we must have the knowledge about the 6n number of coordinates to define the system completely. The concept of the phase space is very useful when we are dealing with the problems regarding the dynamical system, and this dynamical system is actually exist in the nature. To define the phase space, we require the three position coordinates and the three momentum coordinates. Suppose we consider the small element d2. The element is denoted by the letter d, small 2. d2 is equal to, these three are the position coordinates, and these three are the momentum coordinates. So d2 is equal to dv into d2. dv is the position space and d2 is the momentum space. Means the phase space is actually the product of the position space and the momentum space.